Not all errors are mistakes. This video is part of a series that aims to teach the big picture of data science. It is about the what, not the how. It is for beginning data scientists, people who manage data science activities, and others who have some basic math and statistics background and who simply want to understand better what data science is. The topic of this video is error. Let's review the basic statistical model. Y is equal to b sub 0 plus b sub 1x plus epsilon. The first part, y is equal to b sub 0 plus b sub 1x, is fixed. It is an algebraic expression. The second part, epsilon, is random. It is the error component. Notice that the fixed part of the model typically has two parts, the y-intercept and some other coefficients that depict the effect of some x variables that might predict y. Now let's talk about prediction of an unknown using data science methods. A prediction is often designated by a symbol we call 𝗏. 𝗏 is calculated by plugging in fixed parameters and variable values. We see that epsilon is not included in 𝗏. Let's look at how a predictive model gets filled out and put to work in a real-world example. Again, we focus on the what, not the how, but if you have little background in math and statistics, some of this will be very familiar to you. Let's say that management asks you to predict the average order size in dollars next month. To keep things simple, we will not use an x variable. The part of the fixed model containing x will be dropped out. We are left with y is equal to b sub 0 plus epsilon. Y hat equals b sub 0. We will build a simple model where the average dollars per order is predicted from a sample of orders from the previous month. Here we will use a small sample of dollars spent on 10 orders randomly drawn from the database. We see that 10 orders were selected, and they have a wide range of values with an average or mean of $117.90. Our model predicts that each order will have a dollar amount of $117.90. Y hat is equal to b sub 0 is equal to the mean dollars per order. However, the prediction of $117.90 for dollars per order may or may not be a useful prediction for sales. That is where we encounter the random component of our model. $117.90 is the official estimate for the business. This is how we choose to predict future order size. But what if at the end of next month's sale figures show the actual dollars per order was $113.75? Why was the model wrong? Did the data scientist make a mistake? Who is to blame? We should quantify our error. The error associated with a prediction can be labeled as E. Here, E is equal to the predicted y hat minus the actual, so $117.90 minus $113.75 is equal to $4.15. This deviation is known as the residual error. Epsilon is a model of random error, a model of uncertainty of these residual errors. If we understand how the errors behave according to a theoretical model, we know a lot about how to interpret our predictive model. We have frequently noted that a statistical model has a fixed component and a random component. Now is the time to focus on the random component. The random error model might be illustrated by imagining a normal curve distribution as the context for epsilon, which you might have seen in your studies. The normal curve is very well understood in statistics. It is a theoretical model that aids us in reasoning about uncertainty. Looking at the error model, it is bell-shaped. The horizontal axis is the magnitude of error with 0 at its center. The vertical axis is the probability of the magnitude of error. Most errors are expected to be near 0, and the less likely errors are large values in the tails of the bell curve distribution. One advantage of using a statistical model to describe errors is that they let us define the region in which 95% of the errors of prediction would be observed. This is called the 95% confidence interval. Should a manager be surprised if the actual dollars per order in the following month is $113.75? Well, the 95% confidence interval says that dollars per order could fall in a very wide range, and the quantity of $113.75 falls squarely within that range. In other words, it is not surprising at all that the actual dollars per order came in as $113.75. Now, could you blame the manager if they responded, "I understand there was not a mistake, and there is a random error in this prediction, but can't you control the error or make it smaller?" The answer is yes. It is very likely you can build a better model with a smaller error of prediction. Data scientists have a lot of tools at their disposal to improve the accuracy of predictions. This is what you will learn as you continue to study data science. The important thing for today is to get a clear appreciation of the big ideas of data science, a deep understanding of what statistical models do. We have learned so far that data science uses familiar algebra and probability models to provide rigorous predictions and a framework for how the model might perform when random factors come into play.